Hello, I'm Dane, and this is Dan Explains. Last January, I released a couple of compilation videos of my shorts for people who prefer to watch longer videos. I hadn't even been doing shorts for a year, and I still wasn't able to show them all, even though they're only 1 minute each. So I've decided to make it a semi-annual tradition. So today I'm doing a compilation of my select science shorts that I've done in the first half of 2023. So, without further ado, enjoy the shorts. ChatGPT, created and trained by OpenAI, has got a lot of people worried that this thing is too smart. Should we be afraid of ChatGPT? It seems like it can do anything. A lot of people have been spoofing their viewers with scripts written by ChatGPT. I don't think it's a good idea due to left-leaning bias. If we don't believe it has a left-leaning bias, you can't normally ask it to say positive things about Trump, although you can for people like Biden. ChatGPT is a bit like one of those kids in school who can suck up all the info given to them and easily regurgitate the info back. It's all book smarts. It didn't learn this stuff quickly. It learned it very slowly. It takes hundreds of thousands of times. ChatGPT and other AI have to see something so many times is that it's learning how we learn things in reflexive way. It have zero general intelligence. It's the amount of processing power dedicated to the general intelligence that matters. So, unless someone figures out how to give these AIs general intelligence, they will be little more than useful problem-solving tools. What's the smallest a star can be? And what's the biggest it can be? Is there a limit to how big a star can be? If a star gets too big, it becomes a black hole, right? It's only after a star's death that the objects like black holes, neutron stars, and white dwarfs form. We don't call black holes stars because they're black. We do call neutron stars and white dwarf stars, but they aren't in the same sense as our sun. All three are more or less corpses of stars. Well, what about the lower limit? Gas planets are big planets made mostly of hydrogen. Hydrogen just happens to have 3 isotopes. It's deuterium that really blurs the line between planets and stars. Astronomers made a new class of objects to hold these deuterium-burning bodies called brown dwarfs. Some astronomers do consider them stars. If you ask me, if the object is heavy enough to burn any isotope, it's a star. Will probably be debated for some time yet, since we have no borderline analogs in our solar system in desperate need of a definition, unlike planets. Poor Pluto. Is silicon life even possible? What would it even look like? Silicon-based life forms are so common in sci-fi because silicon is very similar to one of the most important elements in our biochemistry, which is carbon. Carbon is like the bones of the molecular world. Silicon is found down one row in the periodic table. Elements, which are in the same column in the periodic table, may have similar properties. The silicon atoms can't get as close together as carbon atoms do. Silicon is the second most abundant element in Earth's crust, just after oxygen. Carbon isn't even at the top 10. Silicon dioxide forms the crystalline solid at room temperature that we know as sand. Most of it's bound up in a crystal lattice rather than free-floating, able to be easily absorbed. That's why Earth life doesn't use silicon, because it doesn't become a gas until it reaches over 5,000 degrees Fahrenheit. Even if the life used a polar ionic compound like a salt as a stand-in for water, salts are only molten up to around 3,000 degrees. There's another chemical that can dissolve sand. That chemical is hydrofluoric acid. A group of people who wanted to call also moons like our moon planets, not Mars's moons. Sorry, you didn't make the cut. So we already have a word that fits the definition world. When I think about the word world, what comes to mind is the Earth. So obviously the sun and a space rock are not worlds. People will describe the moon as a world. Sure, you need a spacesuit, but you would on Mars too. Gas planets like Jupiter and Saturn have no surface. Their atmosphere just slowly gets thicker, going through what's called a supercritical stage. Unlike regular fluids, supercritical fluids have no boundary between gas and liquid. A gas giant is a planet, but not a world. I think a surface you can walk on or swim in is needed to be called a world. Space pebbles have a surface, and you can't walk on those, unless you're an ant anyway. Although the line is a bit blurred, asteroids are space rocks. What do I think is a good definition? A body which is large enough to have reached hydrostatic equilibrium, predominantly due to its own gravity, but small enough to have a solid or liquid surface. You're probably familiar with the question, why is the sky blue? It's one of those questions that kids ask. What is the answer? Could a kid understand it? Most objects with a color have a color because the ambient white light actually contains all the colors in the rainbow. It hits the object and the color parts absorb certain wavelengths, leaving only some of the colors to get reflected back. This is not why our sky is blue. If you imagine light like motor vehicles, red light would be the large trucks, and blue light would be like the small cars. If air molecules are like potholes, a pothole is going to have a bigger effect on changing the direction of a small vehicle than a larger one. So blue light gets scattered into our eyes. There's more to it than that because the sky only looks blue to us because we can't see the color it actually is. Birds and insects can see ultraviolet because it's used by plants. Ultraviolet wavelengths are more like motorcycles on the road and get disrupted by potholes even easier than blue light. So for the animals that can see that part of the spectrum, the sky appears ultraviolet, not blue. Recently, some people on social media were wondering how a homeschooler goes to college and gets a degree. Let me explain how. I'd like to preface that I graduated from college 16 years ago, which means it's been 20 years since I went through the college entrance process. Because I knew what it was I wanted to do, I was able to concentrate on subjects I knew I would be encountering. I was able to de-emphasize subjects I knew I wasn't going to need as much, like history and arts. A big irony, considering most people know me for my art. I was able to take my SATs like any high school student would. I couldn't get a regular high school diploma. I had to get something called a GED. That's the kind of diploma you expect dropouts to get. A real diploma only proves the school was willing to graduate you. When your kids go to college, they will have to make a whole new set of friends when they get there. So it pretty much levels the playing field when it comes to friends. So all in all, I think being homeschooled gave me an advantage over the other students who attended regular high school. With the world's two richest men competing to build the first two-man lunar landers in over 50 years, they have to be better than the LEM designed by NASA in the 1960s, right? The LEM, the interior was barely big enough to fit both astronauts. The new lunar landers will have larger crews of 4, so will have airlocks so astronauts can enter and exit without having to depressurize the whole cabin. The astronauts will be staying inside the vehicle for much longer. The LEM used 2 engines, one for the descent and one for the ascent. The new landers will carry all of their hardware back into orbit. What about the new landers themselves? The biggest difference is the size. The Blue Moon lander will be able to bring 20 tons, and the Starship will be able to bring a whopping 100 to 200 tons. It's like going on a trip in a bus versus a sedan. Blue Moon does have advantages over Starship, however. The Blue Moon could refuel on the lunar surface, and Starship could not. Although, with how cheap SpaceX claims it will be to launch Starships, that might not matter much. What about living on worlds that have some gravity, but not as much as Earth? Can we have artificial gravity when there's already some gravity? In space, how we create artificial gravity is pretty well understood. Get a large cylinder and spin it, and you've created artificial gravity. Doing that on the surface of a world is not as easy. When you spin something, anything inside of it will have 2 forces acting on it. One is the gravity of the world you're on, and the other is the centripetal force pushing you to the wall. These 2 forces work together to create a force vector that is not straight down or to the wall of the cylinder. One fix for this is an idea called a gravity train. You're living on a ring-shaped train that goes around continuously. What about big habitats? Curve the cone to match the force vector. You can make it so you don't have to feel any incline at any point on the inside of its surface. The shape is actually ideal because it fits nicely into naturally occurring bowl-shaped craters, which are common on small airless worlds. You've probably heard of the word superconductor, usually in the context of some sci-fi movie or series. Well, what is a superconductor? Electrons banging against each other isn't a perfect process, and it generates a little heat. Superconductors allow the electrons to move without any resistance. Particles are split into 2 groups, fermions and bosons. Fermions all have spins that are non-integer fractions. The electron, for instance, which is a fermion, has a spin of 1/2. Bosons all have spins that are integers. Particles with non-integer spins cannot occupy the same space at the same time, while bosons don't have to obey that principle. Fermions can work together to create composite particles that are bosons. Electrons in a conductive material are moving around as individuals. If the temperature is low enough, the electrons will tend to form something called Cooper pairs inside the material. If almost all of them are paired up, then the pairs of electrons can start to act like bosons and move through the material together freely. If you like my shorts, I try to release a short every week, a few days before my long form video goes up. Usually Sunday nights. with the exception of this week and last week, of course. Making a short compilation of shorts might be a tad challenging. With that being said, thank you for watching, and until next time, have a great week.